Hey guys, welcome back to the channel. Today we're going to do a project with these Headway cells. These are LiFepO4, so the lithium iron phosphate, not the lithium ion polymer that we normally use with 18650s. This is quite big as far as a cylinder goes. That's because these are 8 amp hour, and so they've got quite a bit of capacity. Not as much as you might expect for something this big, but the other big advantage of these is extreme output. These can do up to 200 amps continuous, I believe. We're going to push it nowhere near that, but it's nice to know that they can handle it. When I saw these, I was like, yeah, what if I wanted to do a power wall or something just kind of more modular, something that wasn't so permanent. These do have threaded screws that go on the top and the bottom, so that makes making packs pretty easy. You just put little bus bars, and then you attach your BMS leads. It's pretty simple, but I wanted something that was a little more like, I don't know, something like this. This is obviously for 18650s, but I wanted something that would be very similar. So I opened up my Fusion 360 and started to design something. So I started out with just a clip, just to figure out how best that clips around there and the dimensions I needed to do and that good stuff. So that's prototype 1. Then I built up to prototype 2. When I started to expand out the links, I started to think about how I wanted to make the connection to the system that's going to be mounted underneath. And from there, just kind of grew, made it a little bigger, and started checking my measurements again. And then, went to a kind of a full size and learned some things. The biggest thing I learned when I got to here is that this distance is hard to nail to get this to fall in correctly. So then I had to realize, okay, I needed to do something like this. And so I had actually ran out black filament as well. But if you notice, this side here is not as tall as this side. That allows this to clip in, and then there's spaces here. So in my final design, I add this block here on top that will socket in and lock it in place, and then give us a place to support the bus bar in there. So if you notice, the bus bars will come through the bottom to the top up here. And then on this side, it's already captured. But on this side down here, I needed to add this and capture it. And the holes there are just so if you want to run bolts through. This is designed so that you can stack these. So if you have a bus bar that's longer, you can just make the bus bar here as tall as you want. And so you can stack these on top of each other. And so let's look at the final prototype here. Bam! All right, so here we go. I added these holes here to make it easier to pop these out because once they're in there, they're actually pretty solid. Again, like I said, this side is a little shorter because I'm going to put those caps on. This side is just normal. I will give you some printing advice right now if you decide to do this. I'll have these on my Thingiverse, but you want to print this at 0.2 millimeter layer height. This one is at 0.3 and it's a little more fragile. The one I did here, that's a 0.2. These clips are nice and solid. I haven't heard any cracking, haven't heard any breaking, but on this one I kind of have, but I don't have time to print another one, so we're just going to go with this. So the idea here is we're going to mount all of these cells in here eventually, but we're going to do all our work here on the bottom. And so these slots here, I've created these copper bus bars, and so they're going to slide in there, and then we'll be able to make our connections series-wise to get 12 volts. And that's where we're going here is a 4S system. And so these will go in either direction. So you can mount them with the tip up or the tip down. Both of them will work. So you can decide how you want to have these. If you want to just say, I'm going to have the tip towards all the holes, you can do that, or opposite. And then underneath is where you can do your series. So you can either bridge from here to here, and then from here to here, and then from here to here, or you can just go, you can do like here to here, but that's kind of long and you have to run a wire. So I'm going to do it so it's like negative, positive, negative, positive, negative, positive, and so forth. That's how I'm going to do it. I'm also going to super glue the BMS down here, run all my trace wires, and then eventually we're going to mounted in here. So this is going to sit on top. And then we're going to have 12 volt output there through banana connectors. That's how we will get our power, and we'll also charge it. And so let's take the next step. We're going to do this off camera, but I'm going to put in the bars and create the solder connections to make the series, and then we'll tune back in then. So see you in a few minutes. All right, we got a little bit of wiring done and a little bit more to go, but I just wanted to show you guys what I'm doing here. We've got our copper leads put in. We've got our main positive, we've got our main negative, and our first little bridge there. We've got 2 more bridges we need to put down here. On this side here, I went ahead and marked which side's going to be positive and which side's going to be negative. So with the power of these, be sure you put them in correctly and that you're wiring everything correctly. Something I'm not sure if I mentioned earlier was that inside of here we have those little holes. These springs will go in and put pressure against the copper plate. They'll really make sure that the contact to the battery is good, so there's no sparks and creation of heat and that kind of stuff. We want a good solid connection. We want this temporary, but we do want it to be a good connection. So that's what those are for. And so let's just finish up the wiring, and then we'll be able to put it together and give it a test. All right, wiring's complete. We've got all our leads, we've got all our jumpers, we've got connected to our banana. So we're going to close this up, install the batteries, and put on the caps on the other side, and we'll be ready to do a quick test. All right, it's all assembled now, and we've got some power probes, and we've got 13.5 volts. So now we have a little pack that's kind of nice to display. It's very portable. It's, modular kind of thing. And in the next video, we're going to show some 12 volt accessories that we're going to use, that we can use with this, and the project before that, that's also a LiFepO4 12 volt system. So I hope you like the project, and if you want to get these cells, you can get them from batteryhookup.com. Use my keyword or discount code TECH. That really helps the channel out since we're pre-revenue. And look forward to hearing some comments or some design ideas, or I'd love to see if anybody actually makes this. These files will be on Thingiverse. And so you guys have a great day. Bye.